Okay, so today we're going to first talk about virtual function. And then after we have virtual function, we're going to ask you to use some program to do participation. But I look at the schedule, I might or might not be able to do that today. So if we cannot finish, we will do the programming part for this on Monday. Okay, so I'm going to talk about a concept called virtual function. I want to actually start with this. By the way, so far when I haven't shared my screen yet. That's something which very important. Okay. Okay, so so far we have covered I would say probably the most difficult topic in the whole ecs36b. Just like in ecs36a, the hardest topic is probably pointer. Inheritance is probably the most difficult, challenging concept in C++. So far we only cover single inheritance. So the flow of my instruction will be single inheritance, which you already kind of know. And then I'm going to talk about virtual function. And after I talk about virtual function, I'm coming back to talk about multiple inheritance. Most of you probably don't know about this, is that C++ actually have two forms of multiple inheritance. One is called multiple inheritance. The other one is called virtual inheritance. This difference is not so significant for almost every other programming language, object-oriented programming language. But in C++, because it's based on C, and because it actually needs to worry about the concept like a pointer. So that's why I say is a challenging topic. So just to let you know, we're actually going to cover that next week, hopefully. It's essentially testing your, like refreshing your knowledge about pointer and addresses, and seeing that the difference between virtual and multiple inheritance, what they do to those kind of concepts. Okay, so that's kind of, after I'm done with that, I think we're done with both chapter 13 and 14. And then we're going to start to talk about the midterm. I will actually give a lecture about midterm, give you a period of time for you to kind of catch up with all the topics, so you will know how to prepare for the midterm. Okay, so this is what we've been talking about so far. It's called single inheritance, means that is a relationship of a one child class, every derived class or child class has only one base or one parent. Okay, so so the idea of a virtual function is this. Is that essentially I define a member function. And this member function is called foo. And you can think about this is dump to JSON, or this function is get distance, get name, whatever, any member function. The thing is that when I actually define in base function and derived function, you can see that I actually can just define, say, there is a member function called foo in the base class, and then also I have a member function called foo in the derived class. So I have two implementation of the same function signature, but it's actually across both the base class and derived class. They both have their own definition of that. Okay, so let me actually just show you what it looks like, okay, in real code. So for example, if we look at thing.h, we look at thing.h, I actually have a function called dump to JSON. have a function called dump to JSON, as you were supposed to start working on that for your homework assignment number 3. And then I have this thing called Internet of Things. And Internet of Things, I also has a function called dump to JSON. By the way, what's the difference between Internet of Things and the thing is that it has a like a network address, we call it IP address. This is the line here that you can actually, whenever you connect to the internet, what is your IP address? That's how it differentiates between the base and the derived. Okay, so the derived is IoT thing, and then inherit from the thing. Okay, so that's kind of the thing. But you actually look at dump to JSON, it has this definition for both the base and the derived. All right, so let's actually go back to the slide. You probably noticed that in the thing.h, I actually add another keyword for virtual in front of the definition of the dump to JSON. Okay, so essentially, you can add a keyword to the member function, or you can actually not have the member function with the keyword virtual in front. And the thing is that I want to ask you is that, what's the difference of these two? So just to let you know, if you add the keyword virtual in front of the member function, then this function became the concept we call virtual function. This is a virtual function as a member function. Okay, this is called virtual function. So just terminology, you know that virtual is converted a regular member function to something we call virtual function. Okay, so that's how we specify. So now let's actually try to write the code. Okay, so I'm going to ask you the question is that I'm going to show you a piece of code, and then you're going to tell me that which of the function will get called. Is that the base or is that the derived? Okay, think about that is thing, and then this derived is IoT thing. So here is my kind of the pseudo code, put it here. So I define something called my base. My base is the class my base is object 1. Okay, I create an object instance that's actually based on my base, and then I create another object 2, which is my derived. Okay, so now you can see that I create two objects, object 1, object 2. And then I actually call the foo function. I said obj1.foo, obj2.foo, and then I said, okay, this is called, I hope you still remember, this is called casting. This is called casting. So I cast a object 2, which is my derived. The class is my derived. Now I cast it with the base. So essentially, I cast from the child class to the base class. So now you can see that I call the function foo, the member function foo, 3 times. And by the way, this is not virtual function. You see that in this example, I didn't have virtual in front of every single one. So I like to ask you the question. Maybe you can show hands. For the first line, obj1.foo, which the base or the derived? It's a base, right? Okay, so this one actually we go to the base. And how about the second one? It's a derived. Okay, good. So you're doing good so far. So now it's the third one. If I have a obj2, but I cast it as the base. I have the derived, I create it as a derived, but I cast it as a base. Then when I call that foo after the casting, which one I'm going to get? It's a base. Okay, anybody disagree? I think he's right. This is actually the 3 things. Okay, so just remember this slide. If is a regular member function, when I decide which version of the foo I'm going to call, I'm actually, the compiler is going to look at the type. of the object before I connect to the function. So in the third case, you can see that I'm actually looking at the foo function is directly connect between the pair of parentheses. And then that parenthesis, the type, the compiler is going to evaluating everything as the type, my derive. My base. So therefore, it's going to call my base. Yeah.
Object 2 as the member function from object 1 that does not exist in the my derived.
Say it again.
Let's say object 2 want to use the function in object my base class, but this function does not exist in my derived type.
Yeah, I will show you an example. How do you do that? I'll show you that example. Yeah. Okay. So I actually have one question, two questions I want to ask you. So the first question you already answered, that this is going to decide which function I'm to call based on the final type of whatever before the dot, right? And which is between the parentheses in this case. And because the data type is my base, then basically I'm going to call the base version of the group. Okay, everybody good with this? So I should ask you, everybody okay with the 3 line here? Okay. My next question to you is that let me ask this question first. If I say, what's the difference between compiler time and runtime? What does that mean to you? Anybody want to provide a guess about what's the difference between when I say compiler time or when I say runtime? What's the difference? Yes.
Compile time means everything that's evaluated when you convert the source code to a binary executable, whereas something in the runtime is decided when that executable is actually running.
Okay, great. I like that answer. So I repeat what you said, is that when you type a make, it try to produce executable, that part of time when you type make is essentially compiler time. There's a little bit different between compiler time and linking, but linking is actually part of the compiler time as well, because it's just linking the code together. So whenever you type a make is usually the make you have been doing for homework 1, 2, 3 is essentially the compiler time. And runtime is when I really run the program, that's called runtime. Okay, so if we are clear about the compiler time and runtime, so I want to ask you a question, is that can we decide which function to call? Which function means is the base or derive in compiler time, in this case? Can we determine that in compiler time? The answer is a yes. Why? I said, how do I decide which version of function I'm going to call? Is actually based on the data type or object type right before the call. So the compiler can actually, what we call static analysis is that I actually look at your code and decide what's the type of that particular clause in between that parenthesis. And I realize I can interpret that as my base because of the casting. And therefore, I can determine which function to call at the compiler time. I don't need to wait until runtime to do that. Okay, that is actually very important. For programmer, you will be surprised. The concept become really, it's not so much, but in virtual function is very critical. Okay, so now I'm going to do this. I'm going to ask you to do the same thing. Everything is exactly the same like the first. Yes.
Could you give an example when that is useful?
The difference between. Yeah. I'll show you just right now actually. Okay. Yeah. All right. Number one. What is the difference between this slide and the previous slide? I mean, just check whether you're sleeping or you're with me until now, okay? Yeah. Virtual, right, exactly. Now I'm adding the virtual in front of everything. Okay, you didn't know the answer, so I'm going to tell you directly what the answer looks like. The answer actually looks like this. Okay, the answer for the first two, if you say object one dot foo, object two dot foo, is going to be the same. Okay, it's going to be the answer is going to be called that one and called that one. By the way, even so, I say it's the same, but the decision-making process is not necessarily the same. I will actually tell you the difference. But I first want to tell you it's going to do is that in this line, that when you call you casting whatever, it doesn't actually like the regular function. It's going to call the base, and then it's actually going to call whatever the might derive. Okay, first I want to tell you that the main difference you should know that if I write the code like this way, my base and object two dot foo, the casting does not help. And then it still call whatever the foo. Okay, so let me actually make it even more interesting. Let me see. Yeah, I have that example over here. So if I write the code differently, it's still this few line, right? And then I actually create my base pointer. Okay, by the way, that's why I said, hey, you need to refresh your knowledge about pointer. So when I define my base, okay, this is a base class, star obj3 underscore ptr. Okay, so this is a pointer, this is the address. And I put this number over there, this number. There's what, you know what this number is? This number is the address of obj2. This is actually the number, the address of actually the casting of the whole thing, of the green plus the red. That's the address, that's a number. And by the way, how do I actually enter that number? I use a scanf. Okay, so I output that number and I scan that number and then I type it in. And then I have that number go to the address, the pointer. And then basically I use that pointer, I call foo. It's kind of complicated because why? Because pointer is complicated. All right, by the way, if you don't remember, pointer is address, it can be treated as a number. Essentially, those three concepts, and by the way, there's another thing, array. In C, pointer, array, address, and the integer, they're the same thing. Right? That's really the smartest thing that whatever who created C try to confuse all the computer science students. Or anybody try to learn programming, I'm sorry, that's the most, I would say, interesting design. Okay, but by the way, so in C, when I write C program, I can actually output the address and then put the address in another format and then interpret that integer as an address or adding, subtracting, do whatever you want. And that's actually why, because if you want to write a computer virus and write a internet worm, and that's a lot of trick people are using to manipulate the address. Sometimes people try to know exactly where you can find particular entry point of a function in your operating system to actually be able to penetrate. How do I do that? I actually know the address and to do that. Okay, but the question I want to ask is that, okay, this one, I can tell you is going to call the derived class. It's not going to call the base class. How about this one? If it's defined virtual function, the answer is that this one still call the derived class. So regardless what I do, oh no, this is actually, I want to go back to here, is that regardless what I'm doing here, regardless how do I mess up with obj2, regardless how do I mess up with a pointer, and when I call this function foo, it's always called the derived class. Okay, that's actually a virtual function. By the way, before I move on, any question about what I showed you so far? Yeah.
The parent class method is virtual. Does the child class method have to be virtual too?
Yes, both of them has to be virtual in order to be effective. Yeah, I mean, usually is if this is a virtual, it should be virtual all the way except the leaf. The leaf can be non-virtual and still all that. Yeah, but anyway, if you want to do virtual function, it's better everything is virtual. You really want to have the effect of the virtual function. Yeah.
So the virtual time testing is basically useless.
Yes. So yeah, that's a good one. I'm going to repeat. So basically, if it's a virtual function, the typecasting in any way is actually ineffective. Yeah. If it's non-virtual, casting will work. But it's a casting, it's a virtual casting won't work. Okay, so if casting doesn't work, how does the program decide which function to call in this case? So how do we, I mean, first, let's not worry about compiler time to runtime. By the way, later, you probably got a hint already. Compiler time, I cannot decide which function to call for virtual function. That's very important. But I want to ask you, just based on my description, can you guess? Okay, can you guess? As a programming language, how do I decide which version of the function I should be called? Yeah.
Is there another piece of data stored, like in the class, like in memory, that specifies the actual class?
There is another piece of information, but it's not about what is the class. It's not the class. So, okay, so I'm going to tell you the answer first, and then you can think about whether this makes sense. So in the virtual function, if it's a virtual, then I would determine which version of the call based on the object, whatever object it is, based on the type of the object at the time of the creation of the object. So by the way, if you look at the previous example, if it's not virtual, I said, well, how do I decide? I'm actually decide the type of the object at the time I'm actually going to ask you that line. What's the type, data type, object type of this line at the time I'm actually going to call it? That is which version I'm going to care. But the virtual function is it's already determined which function I'm to call at the time that this object was created, probably much earlier than this time, right? So that you must create this object at some point. So if this is created as an Internet of Things, then I'm going to call the virtual function that associate with Internet of Things. So essentially, let me tell you, I wrote down the answer already here. So for regular function foo is that the function foo is that the reference class type of the object at the time of the call. What is the object type at the time of the call? That's what I'm going to call. So casting has an impact over here because that's the time when you're going to try to call it. But in the virtual function is different. Virtual function, I still want to decide the class type of that object, but I want to decide at the time of the creation. Okay, one is the time when you call it, one is at the time you actually create the object. Does this difference, you understand the difference? Okay, good. So now I want to ask you the question I asked earlier. Can you do this at compiler time? The answer is no, but try to pretend it's yes. We can do this in compiler time. But how do we decide? How can the compiler actually decide which function to call? If I show you this example, you might say, okay, I'm actually compiling, I'm actually follow that obj2 was actually created as my derived. And therefore, even you casting, I still know that what's the original type at the time. By the way, what is the creation? The time of the creation is here. Okay, this line is a creation, and this line is the execution, right? So essentially, I have to, I mean, if you look at this code, I can say, oh, the compiler can actually go up to actually see where the obj2 was created. It was actually my derived, so I'm going to call my derived. But this example shows that not necessarily. Because in this example, you can see that I just actually print out the address of the obj2 into a long integer, and I actually scan the long integer in, manually type it in, or whatever way you can get it from the network, get it from other place. And I actually put it into a casting. In this case, the compiler already lost the information because of the pointer. By the way, because of the pointer, the compiler, in theory, has no way to determine what's the type that this object was created. So that's why I think one of you asked a question that can we give an example, that this is the example I will give, that the compiler has no way. This I'm talking about C compiler. Okay, I'm talking about C or C++ compiler. You just have no way to actually determine because of that address pointer array integer thing that's actually there. So you cannot do that. Okay, so this is called virtual function. So let me summarize a few things you should learn about virtual function. Number one, how to define a virtual function, adding the keyword virtual in front of the function. Now, that's number one. Number two, what is the definition of virtual function? Is that which function I'm going to call depending on when this object was created. Wrong. The type of the object at the time it was created. Okay, that's actually more important. So that determines which, and then the final thing is that virtual function is not a compiler time concept. Okay, meaning that it's a feature, it's a language feature, but the compiler has no way to find the function. Therefore, as you said earlier, you said there was some information. Yes, there is some information. It's being encoded inside the class, and such that it will do dynamic binding. Whenever you create an object, in fact, let me actually, in homework assignment number 4, homework assignment number 5, you will have a chance to actually look at this in detail. But essentially, when the object was created, I'm actually going to write a pointer to the virtual function in the space of the object itself. So think about that. Usually we say, okay, compiler time, you link the code. But in virtual function, no. Virtual function is that you only write the function pointer, and such that this function pointer, when you call that virtual function, is actually going to retrieve this pointer, and then they're going to dereference and call that function from the address. Okay, by the way, have you learned the concept of pointer to a function from ecs36b? Just want to see. Okay, some of you learned that. Most of you probably. I mean, I know this one. By the way, I think pointer to function is a topic considered fairly advanced in the context of ecs36a. So therefore, depending on how much time the instructor of that particular quarter had. So some of you might got a chance to learn that. Some of you learned it yourself. But I know most of the instructor in ecs36a probably won't have time to actually cover this, because typically it will be covered after you learned about malloc and free. Okay, and so that's okay. I will talk about the concept of pointer to function, because it's so critical to understand how C++ is implemented. Meaning that how do you actually define the runtime system to allow a C++ program be able to handle such kind of things in both compiler time and the runtime. By the way, I just want to say that I assume most of you are computer science major. So here is my a little bit biased differentiation about a computer science major versus somebody who just want to use the language to do some application programming. Is that for if you just want to do application programming, this type of detail is probably not going to be really important. But if you want to pursue a career, is more system level to actually understand a little bit about how language is implemented, how is the performance. For example, virtual function has a huge implication about performance, because if I can do something in compiler, that means I can do a lot of compiler optimization to make sure my code runs really fast. But in this case, I cannot optimize too much at compiler time, because why? I don't even know what is the function I'm going to call until runtime. So that's why it's very significant for CS major. When you try to tune up a program to actually make it run faster, then you know that where is the bottleneck, and whether it's a virtual function or something else is actually slow your program down, or the memory performance. By the way, the memory layout, when I talk about the difference between two kinds of multiple inheritance in C++, it's not just the linguistic of the language. It's more important about the memory usage they have. Is they use different amount of memory when you use virtual inheritance and multiple inheritance. So if your memory is huge, you don't care, doesn't matter. But if you actually care about that, then that's critical. Okay, so just to let you know, that's okay. So I hope you got the idea about what's the difference between the regular function and the member function. So one is reference at the time of the call versus the time of the creation. Okay, so I'm going to show you some real example. I'm going to only show you IoT thing. By the way, I actually forgot. I should actually change this to virtual as well. So if I have a function looks like this, a virtual function, which is dumped to JSON. And if this function is associated with IoT thing, when I casting the object from IoT thing to the regular thing, and then it's suppose if it's created as IoT thing, then suppose I should call this dump to JSON. Oh, that's embarrassing. Okay. So some of you actually asked a question, is that one of the idea of having inheritance is that you can actually put a bunch of different objects from different class, but they all belong to one single base class, say thing. So in this array or vector of objects, some of them are IoT things, some of them are thing, some of this are shadow things, some of this are other thing, but they all got casting into things. So when I look at the vector, it's still thing. But when I actually pull one out, when I try to call this function dump to JSON, then I want them to call exactly at the time, at the member function where it was created. So regardless, you can actually just casting your thing throw that into that set, that bag, and you just close your eyes, you pull one object out. And this object, when you pull out, looks like it is a thing, but you don't know what it was created. You have no way to know. But now when you call it, it will actually automatically figure out which one to have. So let's actually take a look at the implementation of IoT thing. So, okay, this is the function, how I implement dump to JSON. This view line. Okay, let's actually take a, let me make it a little bit bigger. Okay, I'm looking at this view line. Look at this. The first thing is that I want to implement, I want to dump the whole thing. By the way, if this object was created as IoT thing, then virtual function guarantee I'm going to call this. But when I come to this particular function, I still want to dump my parents because I still have that one that I inheriting from the base class. So I want that part to be there. So look at the first line. This is the way I actually can do it. So how do I do this? I actually create another object. I create another object called thing parent. And what is thing parents? That I use bracket initialization. By the way, this is a copy constructor. So I'm using a copy constructor to copy the parent portion of my cell and actually copy into another object I just created called parent. Okay, this parent is just a variable name. Okay, so essentially what I did is I actually create an object that's actually called parent, and the creation time is a thing. So now you can see that now I'm actually going to do, I call parent dot dump to JSON. So now if I do call parent dot dump to JSON, given that it's virtual function, should this be the thing version of dump to JSON, or should this be IoT thing version of JSON? It's the thing, because why? At the time of the creation, when it was created, it's just one line above. What's the type it was created is thing. So by the way, after this line, the result is the JSON value interpretation about what happened to my parent equivalently. Okay, that's not everything I want to do. But then I actually got a dump JSON to the network. What is it? Disconnected. Disconnected is IP address. So essentially, I actually call the IP address portion of the IoT thing. I actually got it out. And then after I got that, I actually just, you remember what's the result? The result is I already just created from this line, the parent part, and then I integrate the JV result, which is the connected part, into that keyword result connected. Now you see that I actually implement the whole dump to JSON in this virtual function. So the difference between this function and the thing.cpp's dump to the dump to JSON, the one important difference is that this piece of code is not in your homework 3. But this piece of code is actually in your homework 3. Okay, so I'm not going to show you that piece. Okay, but just imagine that how that works. Okay, I'm just kidding. But the real thing is that I actually will be able to still call the parent dump to JSON, even if it's a virtual function. I can still call it because in this case, I need to have it. But if you want to call your JSON, call your parent's virtual function, you better duplicate yourself to a parent object first, like what I did here. Then you can actually call it to get whatever result you want to get, and then integrate that with this, okay? So this is yet another lesson about how to handle virtual function is that it's really you understand that the decision making is based on the type when the object is created. If you follow this rule, it's actually pretty tricky. The more you use virtual function, is both, I would say, tricky in some sense, but is also very powerful in some cases. Okay.
So I think for the second dump to JSON, is that the computation in the parent class or the derived class?
This dump to JSON is related to this connected. So let me actually show you the code. That piece of code I can show you. So if you look at IoT thing.h, the connected is belong to a class called IP address. Okay. So now if I go to network, IP address was defined in network.h. Network.h has an IP address. It actually has also a function called dump to JSON. Okay, and now let's actually take a look at network.cpp. If it's network.cpp, over here is the dump to JSON. So essentially, we're calling this function from the network.cpp. You can see that I'm actually trying to implement such that I actually using the function call. This is actually a Unix function call. That's why we need to include like ARPANET in the include file. Is I call this function called inet n2a. It's actually help us to produce that IP address.
We have to use dump to JSON multiple times, and they are from different classes. Why don't we have some suffix after the dump to JSON?
What?
Why we can have some suffix after the dump to JSON to identify which class is from?
Oh, maybe that's intentional. Because if you think about the case, okay, it's a good question, but I want to tell you that if I have a vector of object, every one of them is actually thing. This is a vector of things, okay? This is a vector of thing. And then inside here, I have a lot of things, right? Everything is a thing in this vector, but some of them are just regular things. Some of them are IoT thing, and some of them are shadow thing. But when I actually call, I actually don't need to know. If I actually add, say, this is dump to JSON for thing, dump to JSON for IoT thing, then essentially it's a programmer's responsibility to find a way to realize this thing is an IoT thing or is a shadow thing. In this case, I just call dump to JSON, regardless. Okay. Any other question? Okay, I'm going to give you a very quick preview about what we are going to do the first thing in Monday. Just give me 30 seconds. I'm actually going to give you a new class called shadow thing. You heard me saying things about shadow a lot, but it's a shadow thing. So shadow thing is essentially an object inherit from thing. And it also has a virtual function called dump to JSON. But let me show you what is the shadow thing. Not shadow thing, actually. Yeah, okay, I can show you shadow thing. That's okay. But if you look at shadow thing dump to JSON, does this sounds familiar to you? This piece of code. This looks familiar to you. Where do you see this style of code? Where did you see this style of code? Yeah. JSON RPC, right? This is actually over 0 or the participation credit that you actually done. So you see that I'm actually calling this particular function called dump to JSON, but it's actually trying to connect to something else through JSON RPC. This means that this object, this shadow thing, It's actually not on your computer. It's actually on my computer or some other device. So think about that when we're doing C+ programming. The first question you should ask yourself, are you sure you have this object? Are you sure this object is on your computer or somebody else's computer? Do you care? With this shallow thing with the virtual function, you probably don't care. Well, it's a good thing or bad thing, I don't know. Okay. So when you access a credit card, that credit card is not your credit card, it's my credit card. So you charge on my credit card. What's a nice thing to do, right? For example. Okay. So we're going to show you because when you actually try to dump the JSON, you actually dump to my computer. Okay. We'll see that on Monday.